categorized into two, which are rigid and flexible structures. They both differ in terms of their mechanical properties. For instance, the size of rigid structure is bulky and heavy, meanwhile, the flexible one is thin and lightweight, which consequently affect the other properties like energy consumption and system response. The implementation of horizontal flexible plate structure can be seen in solar panel, car parts, conveyors, and many more. Although rigid structure able to withstand high load, it is however unsuitable for application that require lightweight material for the operation. Hence, flexible structure is used to replace the rigid one. However, the aforementioned structure has less stiffness, which causes it to vibrate easily and affect the system performance, which consequently cause the system disruption. Therefore, an effective control needs to be developed in order to cancel the vibration. Passive and active vibration control are two types of control strategy utilized in industry, where PVC apply mechanical devices such as damper and spring. This technique only suitable for high-frequency application. Contrast to PVC, AVC is used to reduce the vibration at low frequency, utilizing the electronic devices such as sensor and controller. This innovation aimed to design a PID controller tuned by crowd search for the cancellation of the undesired vibration of the horizontal flexible plate structure. This research utilized system identification method, which consists of 4 steps. Initially, an actual vibration data is collected by integration of instrumentation and data acquisition system into the experimental test rate. The properties of flexible plate is outlined in Table 1. Next, the optimization process, which utilizes the swarm intelligence algorithm via crowd search. Crowd search was introduced by Askazadeh back in 2016. This approach was inspired by the crowd intellectual in memorizing their hidden food position. Their behavior prevents the other crowds from stealing their food. There are 4 basic ideas from this algorithm, which are: in order to obtain the robust controller, an accurate model of horizontal flexible plate structure was developed first, and then it is implemented in the PID block diagram in the form of transfer function. PID gain is located before introducing the disturbance, which act as vibration. The PID gain was tuned using crowd search algorithm to find the optimum values of Kp, Ki, and Kd for achieving the best attenuation level in suppressing the undesired vibration. Before the activation of the PID controller, a sinusoidal graph has a magnitude of more than 1.5 decibel. Activation of the PID controller based on the crowd search is activated. We can see that the graph of the sinusoidal has been suppressed in this scope. After the fine-tuning of PID-CS using trial and error approach by varying the parameters value, the best value to obtain the minimum PID gain is highlighted in the last column. The PID gains obtained are as follows. The first analysis of the controller is conducted by exiting the system with a single sinusoidal disturbance. These two graphs represent PID controller in time and frequency domains. From the analysis, the obtained parameter gains for PID-CS based controller has successfully attenuated the first mode of vibration with 44.75 decibel, which equivalent to 42.7% attenuation. In order to test the robustness of the developed controller, the analysis is continued by exiting the real disturbance to the system, whereby the disturbance is simulated based on the experimentally collected actual vibration data. The same value for PID parameter obtained in the single sinusoidal disturbance was set for the real disturbance to compare its effectiveness. From the result, The maximum attenuation achieved by PIDCS based controller under real disturbance is 44.72 decibel, which equivalent to 81.9% attenuation. It is noticed that the performance of the controller under real disturbance is increased by raising the percentage of reduction in the system. Here, it is proof that the developed controller is very robust even the system is exerted with experimentally collected real disturbance. The novelty of this experiment are as follows. The advantages of flexible structures are not only it will save money in terms of less manpower required for producing goods, it is also save space due to its small size. Other than that, by implementing the controller, the effectiveness of the system can be guaranteed because it's aimed to achieve the desired output. The main important thing is it could prevent death by less impact on the person if any disruption occurs. Besides light in weight, the simple geometry of flexible plate can be easily manufactured to suit the industry purpose. For example, the conveyor belt and intelligent service robot in food industry, the automated retrieval system in warehouse which increase the storage efficiency with minimum human error. In the pandemic era, the usage of horizontal flexible plate structure is widely applied in medical industry by placing and delivering the food and medicine on the tray carried by autonomous driving vehicles to avoid human contact. This structure also has high potential in logistic industry by delivering goods to customers using drone.